The method for working out the modulus and argument of complex numbers is to draw a diagram and use common sense. There's the diagram, and as always we can work out the modulus by using Pythagoras. We've got to think a little bit about the modulus. The angle marked theta is inverse tan, or arctan, of opposite over adjacent. In other words, arctan of 2. But the angle we want, the modulus, is measured from the real axis, the positive real axis, anti-clockwise, and so that's equal to pi by 2 plus this angle. Alternatively, we could have worked out this angle instead, which is arctan of a half, and then subtracted that from pi. So there are two possible ways of writing the argument, equally good. Now we can work out the modulus and argument for Z2 in the same way. Pythagoras for the modulus, and the argument, measured from the positive real axis, is arctan of 4 over 2, or arctan 2. These are our answers for the first part of the question. Now that we've worked out the modulus and argument for Z1 and Z2 separately, we can calculate the modulus and argument for the product, Z1, Z2, and the quotient, Z1 over Z2. You should have these four formulae memorised. First of all, the modulus of the product is the product of the moduli, so that's root 5 times 2 root 5, which is 10. Then the argument of the product is the sum of the arguments, so that's going to be pi by 2 plus 2 arctan 2. For the quotient, the modulus of the quotient is the quotient of the moduli, so that's root 5 divided by 2 root 5, that's a half. And then of course when we're doing the argument of the quotient, it's the difference of the arguments, so that's just going to be pi by 2